8.3.2. Tabo bought a house costing 1.5 million and used his savings as the deposit. He obtained a home loan for the balance of the purchase price at an interest of 12% per annum compounded monthly over 25 years. He made his first monthly installment of 11,058 towards the loan on the 31st of July 2018, which would be a month after he got the 450,000. So we will be assuming that he's making the payments at the end of the month. So we need to read it again and highlight the important information. So we are told that he bought a house costing 1.5 million. He then uses the 450,000 that he saved up as a deposit for the home. So he now takes out a loan for the remaining balance and says he will pay it back over 25 years, and the bank offers him at an interest of 12% per annum compounded monthly. He made his first installment here, so we have the monthly installments he'll be making, and the first question reads as follows: what will the balance outstanding on the loan be on the 30th of June 2039? This is 21 years after the loan was granted. So 21 years after the loan is granted, we know this loan has a life of 25 years. So if I draw a very high level timeline, we have here he takes out the loan, and here he finishes paying out the loan. 21 years would be somewhere over here. 21 years. Now this problem, you can solve it two different ways. First of all, there's one direct formula that you can use. So we've used the future value formula, but there's also the present value formula. Now with the present value formula, it tells you at a specific position not how much you have saved. No, it tells you at that specific point in time how much do you still owe, how much do you still have to pay. So the amount of time that you use, or n, within the present value formula, which has the following formula: P is equals to X for monthly installments, 1 minus 1 plus I to the power of n all over I. In this case, n doesn't mean the amount of years that you have been paying back the loan. N represents the amount of years or amount of terms, the amount of payments that you still need to make. So it's the deficit. In this case, it will be described by this region here, which is 4 years. And this is compounded monthly. So we use that 4 in n, and everything else we can keep it the same. So X, we know what X is, the monthly installments of 11,058, and we have 1 minus 1 plus, the interest is 12%, so 0.12 over 12, and how many compounding terms? And excuse me, here it's supposed to be raised to the power of minus n, and that would be minus 4 times 12. Then we close that big bracket and put it all over the interest, which is 0.12 over 12. We find that at or after 21 years, the amount that he still owes would be 419,948 and 32 cents. Now this is one way to solve it, and it's the quickest way. The other method uses the other period of time, which is this one. So what's nice about this formula is it accounts for the growing interest rate of the balance. But if we were to use future value, it only tells us the interest on the amount that we are paying, or that Tabo is paying. So the other alternative is to use this formula. So we'd say our balance would be how much has accumulated, how much of the loan has accumulated, minus how much has our payments, counted for. So at the end of the 25 years, we know this balance would be zero because it would be settled. But after 21 years, we know that the amount we are still owing is more than the amount that we've paid back so far. So what we do is we use, for the growing amount, we use compound interest, which is 1 plus I. And then for the payments that we're making, we use the future value. So we are subtracting this amount, 1 plus I to the power of n minus 1 all over I, like that. Then basically you can solve it from this point on by inputting the values that you can see from here. Here we know that the present, or the principal amount, will not be 1.5 million. Rather, it would be 1.5 million minus 450,000, which would give us 1,050,000. This is because he has already paid a part of this amount that is borrowed from the bank as deposit for the home. So he only takes out a loan of 1,050,000. So that would be your principal amount. The interest, it's growing at the same rate, so it's 12% per annum. Same thing with the interest over here, it would be 12% per annum as well, and it's compounded monthly, so it's important that you divide by 12. So if we were to make our substitutions, we would have for the principal amount 1,050,000, and then 1 plus 0.12 over 12. And how long has it been in there for? How much interest has it accumulated? And it has accumulated interest over the 21 years because that's the period we're trying to evaluate it at. So we would say 21 years compounded monthly, so 21 times 12. Same thing for this. For your number of compounding terms, which is n, that's just going to be 21 times 12. And our x, which is our monthly installments, that is going to be the same value as the previous one, so 11,058 and 85 cents. And then the interest, again, that will be 0.12 divided by 12. But you realize if you compute this sum as well, you get the same amount, which is 419,948.32.